Hi, this is Leo. I'm here to present the ZotoMind. So what motivates me to build this product? I'm a very heavy Zoto user for my research. I really need an external tool for help me to connect the information inside my paper collections. But the existing methods, the existing tools cannot satisfy me, so I decided to build a new one. The first step is to convert the PDF files into some format that can be understandable by GB4 or large models. But the traditional OCR method very usually fail to convert paper into those structured formats like LaTeX or Markdowns. And the traditional regs or very straightforward regs fail to retrieve unstructured information like LaTeX or tables and images. So let's talk about various methods like DB4 or RAG. They are actually the same thing. We can see that the PDF loader utilized by it's not satisfying. There are a lot of messy words. And also there are some emerging tools based on large models like size-based or Elicit. Those are from our core code tools presentation. We can see that this is the original paper, and this is encoded by those two tools. It also not satisfying, and I don't think it can be understood by the large models and retrieve the relevant equations for the users. In terms of data source, the only data source is the papers from your own Zotero collection and is achieved through the Zotero API. All of the papers can be embedded once you provide your own API key. So here is the pipeline. First, the PDF papers will be converted into Markdown with Nougat, and the Markdowns are checked by the header to maintain the semantic information in those equations. Then we utilize YOLO to identify and extract all the images from the papers, and then the markdown, the tables, the figures are all embedded through the GB4. So let's talk about our PDF to Markdown converter. That's Nougat. Nougat is based on Donut. Donut is a vision transformer based autoencoder. So its input is the image and structured prompt. So those can guide the vision transformer to learn structured information from the image. Nougat utilize the same structure with Donut, but it's utilize another format that's Markdown. So the LaTeX from the archive are utilized from the Markdown format, and the Markdown dataset are utilized to train the Nougat. So it can convert the PDF data into the Markdown format. We can see that compared with size-based and Elicit, this is the same paper. We can see that all the equations inside it can be encoded into very accurate LaTeX equations. So the Nougat is deployed on the Hugging Face by myself. In terms of non-deep learning approach, that's OCR, traditional OCR. The only traditional OCR is GOCR, and we have proved that with Tommy, with Irene, and Rishabh in the module one, we have proved that deep learning OCRs are much better than traditional OCRs. But the results generated by deep learning OCRs are not promising either. So vision transformer are much better than them. In terms of YOLO, we use YOLO to identify images from the PDF. So the YOLO are trained with 4 different classes to extract different elements from PDFs. We only use the image class from it. Here is the images extracted by YOLO. And this is my pipeline. There are three key elements: that tables, figures, and latex. So the paper are processed by YOLO and Nougat to extract three different information. So latex can be easily embedded by GB4, right? But tables and figures, they are unstructured information. So to retrieve it, we need to encode it with text. So we use GB4 to GB4 vision to summarize the information contained in the image and use that as a label together with original images, embedded those into the vector database. However, there's one issue is that since those images are extracted independently, so it may cause loss of the context. I use GB4 to generate another paper context to the GB4 when it generating the summary for the images. So I wanted it to provide more content information. Those three types of information together with the paper will be encoded into the vector database. So our native approach is size-based illicit. So ZotoMind is much better than those two because it supports latex. It encodes the PDF into structured ways that can be easily understood by larger models. So you can utilize all of the information inside the paper. And also the unstructured information like images can also be retrieved by the ZotoMind because we have YOLO and semantic search way. For the evaluation, I use eyeball test. So I test some examples. ZotoMind is really excellent in retrieving the latex equations. It can accurately retrieve the latex text from the original paper to answer the user queries. But it's still weak at retrieving images. So there are some reasons. First, even though I provide some context information, but that context may not relevant to the images. For example, there is a bar plot in the experiments. So its context is in that experiment position. So the context generated by me is actually the abstract paper may not relevant to that experiment. So that may confuse the model and fail to retrieve the relevant information for the user. And also the title of the images are usually ignored by YOLO. That's also a very important source of information. So the main contribution, so ZotoMind, that I build a persistent and independent retrievers for different users. Once you input a Zotor key, it can build a retriever for you. This cost me a lot of time because long chain does not support the storage of retriever, so it's only stored in memory, and once you stop running the code, it will be erased from the memory. So I discussed with the developer of long chain, and he suggested me to rewrite the original function. And finally, I made it. And the ZotoMind is perfectly combined Nougat and Rack. We can see the latex retrieval is very successful. And the most important thing is that ZotoMind can connect all the information inside your paper collection and inside your Zotor collection. So that's very that's also a success for me. That's my presentation. Thanks. See now all the keys are all site. We can check this site to check whether your vector database is updated according to your paper collection on Zotor. And you can update your database So their example, this is just example. If it will illustrate, it will list all the so okay, we can see that there are all the keys are assigned. There is a guideline of how to find your Zotero API key. Click check data site. You can see whether your vector database is updated according to your Zotero paper collection. And if it's not, you can update your vector database. It will list all the papers that are not in your vector database. Now let us ask the first question. Can you explain the theory of GCNs with latex equation? We can use this query to get it to generate some latex equations. And we can prepare for the next question. Oh, there are some mistakes. So maybe sometimes when it retrieves the information, it can cause some missing of some symbols, and it can cause some error. But most of the cases, it runs smoothly. So in my vector base, there is a paper that explains the theory behind the GCNs. Those equations are all retrieved from that paper. And we can get the ZotoMind to retrieve some images. Can you illustrate the structure of PTM? So this is a large language model structure. We can ask him about it. It successfully retrieved the relevant figures. So the output contains all the relevant images. So there may be some overlaps. So that's my demo. Thank you.